Our next example, we're to graph 3x subtract 2y equals 8. 3x subtract 2y equals 8. Remember that the four forms of the equation that we were to work with are y equals mx plus b, ax plus by equals c, y equals b, x equals a. The example we just did was of the form y equals mx plus b. Example 2 is of the form ax plus by equals c. A number times x, add, this says subtract, but of course that means add the opposite. A number times y equals a number. And so this one is of the form ax plus by equals c. How do we proceed? First, solve for y. First, solve for y. A crucial step. First, solve for y. Be sure you do this. First, solve for y. Well, to solve for y, we copy the equation and then proceed to get y by itself. 3x subtract 2y equals 8. We're trying to get y by itself. That means we must remove the 3x from the left-hand side. We will do so by adding its opposite or subtracting 3x. So I'll write 3x subtract 2y, subtract 3x equals negative 3x plus 8. So the extra thing I've put on each side is a negative 3x being added to both sides. On the left I wrote it as subtract 3x instead of add negative 3x just to save trouble. On the right I had to write it, of course, as negative 3x added to 8, since I'd like the x term to precede the constant term on the right-hand side. Now on the left, the 3x subtract 3x cancels, and I get negative 2y equals negative 3x plus 8. To get y by itself, I must divide by its coefficient. The coefficient of y is negative 2, and so we divide both sides by negative 2. On the left, the negative 2 and the negative 2 divided into it cancel. On the right, the negative 3x plus 8 divided by negative 2 means that negative 3x is divided by negative 2, and 8 is divided by negative 2. So this gives me negative 3x over negative 2, which is 3/2 x, plus 8 divided by negative 2, which is negative 4. And so we have y equals 3/2 x subtract 4. Y equals 3/2 x subtract 4. We have solved for y. Now y equals 3/2 x subtract 4 is of the form that we used in the preceding problem. This is of the form y equals mx plus b. Remember, subtract 4 means add the opposite of 4, add negative 4. So y equals mx plus b is the form of our equation. So all we have to do to solve an equation, to get an equation of the form ax plus by equals c into the preferred form, is to solve for y. Once you get y by itself, then the form is back to what we prefer. Now we can tell from this form what x values will be smart choices. Notice that the fraction coefficient of x has a denominator of 2. That means that the x choices that we would choose should be multiples of 2 if we want to remove the fractions. I will choose negative 2, 0, and positive 2, just the way we did in the last example. Negative 2, 0, and positive 2 for solving this equation. So my table of values begins with the x column, negative 2, 0, and positive 2. We find the y values to go with these by simply substituting the x number in place of x First the negative 2, then the 0, and then the 2. So let's put in the negative 2, and we get y equals 3/2 times negative 2, subtract 4. As promised, the 2 denominator cancels, so that we get 3 times negative 1, subtract 4. 3 times negative 1 is negative 3. Negative 3 subtract 4 is negative 7. And so our first ordered pair is negative 2, negative 7. Next, we'll fill in 0. We write y is equal to 3/2 times 0, subtract 4. 0 is our favorite because 3/2 times 0 is 0, and 0 subtract 4 is negative 4. Last, we'll fill in 2. Y equals 3/2 times 2, subtract 4. Y equals 3/2 times 2, subtract 4. The 2's cancel. And this gives us y equals 3 times 1, subtract 4, which is y equals 3, subtract 4, which is negative 1. And our ordered pair is 2, negative 1. So the 3 ordered pairs are negative 2, negative 7, 0, negative 4, and 2, negative 1. Now let's put them on the graph. And we have an x-axis and a y-axis. You might notice that the y-axis I have drawn is not split exactly in the middle by the x-axis. I put the x-axis up a little higher than the middle. Why is that? Well, the reason is I know that I'm going to be graphing a low value of y, which will be down low, 7 below the x-axis. And the highest y value I'll be using is negative 1, and that is also below the x-axis rather. So since the y values are all negative, and they go down as far as 7, I can slide the x-axis up to a higher level and have plenty of working room down here for these negative y values that I'll be using. You see, it is not absolutely necessary to make the x-axis split the y-axis exactly in the middle. Well, let's graph negative 2, negative 7. Starting at the origin, we count to the left 2 and down 7. 1, 2, 3, 4, 5, 6, 7. 0, negative 4. Start at the origin, we count 0 sideways and 4 down. 1, 2, 3, 4. 2, negative 1, we start at the origin and count to the right 2 and down 1. Do these 3 points line up? Let's see. Yes, they do. And so I can draw my line all the way across the picture with arrow points on either end to indicate that the line does not stop there. Let me remind you that when you draw a graph, if you do not indicate otherwise, the reader will assume that each space represents one unit. And so the reader should be able to identify this point as 2 to the right and down 1. The reader should be able to tell, without you writing the coordinates on here, that this point represents the point 2, negative 1.